All right, let's go over the problems we did in class. So this was on the PowerPoint slides, or rather the Google slides. So you have a 2.5 kilogram puck, and you have a frictional force of 2 newtons. So your force due to friction is 2 newtons. And you want to find out what the coefficient of friction actually is. So what is the coefficient of kinetic friction? Now the formula for your force due to friction is something we did in class again, right? So it's your force due to kinetic friction is coefficient of friction times normal force, right? So here, what we need to do is, well, what's Fn, right? So there's a piece of this puzzle missing. We don't know what Fn is. Well, if you think about it, it's also something we talked about. This puck is on the ground, right? And it's not moving up or down. It's definitely moving in horizontally, but it's not moving up or down. So we have a normal a gravitational force pulling down, and we have a normal force pushing upward. Well, what we can say is that, well, Fg is equal to Fn, or rather, what we can say is that our total net force in the y direction is 0. And so Fn minus Fg is equal to 0. Well, if we add Fg onto both sides, we now figure out, well, Fn is equal to Fg, your force due to gravity. Fg is equal to mg, right? That's the formula for force due to gravity. So, well, if Fg is equal to mg and Fn is equal to Fg, well, we can just say Fn is equal to mg, right? Because it's basically the same logic here. If A is equal to B and B is equal to C, well, then A must equal to C, which is basically what we're doing here. If you don't know what G means acceleration due to gravity, and on Earth, your acceleration due to gravity is always 9.8. G is just the positive version of acceleration due to gravity. So your force due to friction is 2, right? And your normal force is mg. So 2 is equal to u, 2.5, 9.8. Right? And you divide by 2.4, 24.5. And your coefficient due to kinetic friction between the puck and the shuffleboard is 0.082. Let's do another problem. A block weighs 100 newtons, right? So this block weighs 100 newtons. And we know that weight, right? Newtons measures a force. And we know that weight is actually your force due to gravity. Weight and force due to gravity are the same exact thing. So you have your force due to gravity is 100 newtons, right? And so the magnitude of the minimum force, right? That's what you're trying to find out. What is the magnitude of the minimum force needed to start the rubber block to move? So you need to know what your applied force is, right? What is the applied force necessary to move this block? And the rubber block. And you're given a piece of information here, right? So the rubber on dry asphalt. Rubber on dry asphalt is over here on your coefficients of friction table. and the object is initially resting. So the frictional force that you're going to encounter here is static friction. So we're going to work with this coefficient of a static friction here. So we're going to use the static friction version of your coefficient of friction. So you get 0.85. But what exactly is the problem asking you for, right? They're asking you for what is the minimum force necessary to move this rubber block? Why phrase it like that? Why phrase it like that? Hopefully you remember the simulation, right? Because no matter, we need to overcome a certain amount of force for the object to start moving. If I apply the force of 120 newtons, the object will still not move because the frictional force is 120 here, right? And so there's a maximum static frictional force that you must overcome to get the object to start moving. And so for this crate and this surface, the max static frictional force is 125. And if you go over that static frictional force of 125, you get the boxes start moving. And so we need an applied force that is greater than our force due to static friction. And how do we calculate our force due to static friction? Well, we just do the same formula for force due to friction. So we just plug it all in. Fs is equal to Us Fn. And we know that Fn is equal to Fg. So 0.85, 100, and then you should get 85 newtons. And so as long as your applied force is greater than 85 newtons, you get the object to start moving. So let's do this one. So you have a 70 kilogram skier. And the slides on wax skis along a horizontal surface of snow. So you know you're looking for this. You know the person is moving, right? So you know the person is moving, so you're dealing with kinetic friction here. So it's 0.05. What is the horizontal force required to push him forward at a constant velocity, right? So again, what is the horizontal force required to push him forward? Well, if the person is already moving, and you want him to travel at a constant velocity, well, what you actually need to do is you need to make your sum of all forces 0. And so now you're traveling at a constant velocity, which is indicated by the speed counter over here. So for you to travel at a constant velocity, your net force must be 0. For your net force to be 0, both your applied force and your frictional force must be equal. Right? So your applied force must be equal to your frictional force in this case. And in this case, this is a kinetic friction, right? Because the object is moving. So we need to equate. We need to say that, well, F applied is equal to your force due to kinetic friction. And so And we know that my force due to kinetic friction is equal to U, K, Fn. And so what is normal force equal to? Mg. Solve it, and then you get this. And so your applied force is equal to 34.3. Let's just do this real quick. What is the minimum horizontal force required to start a 700 Newton steel block? So you know that the weight is 700 Newtons, right? And so B, steel block on block, steel block on a steel table. All right, guys, I pause for a second. So steel on steel block. So the object needs to start moving. So you're clearly looking for the static version. So 0.74. So now, so okay. So now you need to know what is the minimum horizontal force. And you know to move an object that's just at rest, you need a force that's greater than the static frictional force. So you're trying to find out what your static frictional force is. The static frictional force is US Fn. But you know that Fn is equal to Fg. So 0.74, 700. That should give you 518 newtons. Okay. So you have a 200 Newton rubber block. What is the magnitude of the force needed to keep a rubber block moving at a constant speed? So if you need to move it at a constant speed, you know your force applied must equal to the force due to kinetic friction. It's a rubber on asphalt, right? So it's rubber on dry asphalt. And so you know the object is moving, so you're working with kinetic friction. So the coefficient for kinetic friction is 0.67. And you also know what Fn is equal to. Fn is equal to Fg, which is equal to 200 newtons. All right, so now all you're going to do is plug in your numbers. Fk is equal to 0.67, 200. Divided by 3. What's this divided by 3? 12.67. Hold on. 100 and I'm sorry, 133.3 newtons. And so that's a minimum, that's the magnitude of force required to keep it moving. All right.